taken from the question paper of April 2012. This question 1, because question 2. Figure below shows a graph that depicts the velocity of a vehicle respective to time. Movement takes place in a straight line. So this is the given graph. And the first question says, from the graph, determine the following: the acceleration. Now you must be able to analyze this graph. This graph starts from 10 and is constant for 35 seconds. After 35 seconds, it accelerates. The velocity increases from 10 to 25. 45 minus 35. So you must be able to analyze the graph. 45 minus 35 will be 10. So it accelerates for 10 seconds. Now to answer the question, it says calculate the acceleration of the vehicle. It is accelerating. The slope of a velocity time graph represents the acceleration. So it's accelerating there at that point. So question 2.1.1. From the formula V equal to U plus AT. When you make A the subject, A will be equal to V minus U divided by T. This is from the definition of acceleration, that A equal to the change in V divided by change in time, rate of change of velocity. Now, the velocity, the final, from this point to this point, final velocity there is 25 minus initially is the starting point, so the velocity is 10. Then you divide by the time corresponding to 25 is 45, and the time corresponding to 10 is minus 35. Then you use your calculator to get the answer. This will be 25 minus 10 divided by 45 minus 35. And the answer will be 1,5 meters per second squared. So when calculating acceleration, always get positive answer because the speed is increasing. Second question says calculate the velocity after 40 seconds. So the 40 seconds is somewhere there. This is the unknown velocity. What is the velocity corresponding to 40? Now to calculate this velocity, you can calculate it or you can measure it by using the scale to sketch a graph. To calculate it, 2.1.2, we're going to use from this point to this point up to 40 seconds. Same formula. Acceleration is equal to V minus U over T, or V equal to U plus AT. So this is the initial of this line. And this velocity that is unknown is the final from here to here. So V is the unknown, equal to initial starting from 10 plus the slope of this line is the same throughout. So it means acceleration will remain 1,5 at any point along this line. So it's 1,5 multiplied by the time taken, which is the time under this line. So it will be 40 minus 35. 40 minus 35 is 5. So V will be equal to 10 plus 1,5 times 5. 1,5 times 5. The answer is 17,5. So this is 17 5 meters per second. So it means after 40 seconds, the speed of this vehicle was 17.5 meters per second. Question number 3. Question number 3, 2.1.3. You calculate the total distance covered by the vehicles after 45 seconds or during 45 seconds. So you are looking for this total displacement. Displacement is the area under the graph. So this area represents the displacement. Now, there is no formula that you can use to get the area of this shape. So you need to section or to divide it into triangles and rectangles or square. Doesn't matter how many shapes you divide it into, but as long as you're gonna include or add all of the shapes. So if we divide it here, we section it here, this will be the rectangle. So we can label it as area 1. This will be area 1. And again, we divide this. We can label this one area 2 and this area 3. So there are 3 areas in total. Now, total area AT is equal to A1 plus A2 plus A3. This is going to give us the total area. So the total area under this graph represents displacement. Area 1, to calculate the area of a rectangle, is L multiplied by B. And this is also another rectangle, it's a square, because this is 10 and this is 10. So this is a square. We can use L times B or L squared. And area 3 is a triangle. So the formula to calculate an area of a triangle is half times base times height. Now we substitute the dimensions of this rectangle. It is 10 by 35. So this will be 10 multiplied by 35 plus the dimensions of the square. This side is 10 and this side from here to here, this base is 45 minus 35, which is also equal to 10. So this will be plus 10 by 10. The triangle, it will be plus half. The base of the triangle is this one from here to here. So it will be half times 10 multiplied by the height. The height of the triangle is this base from here to here. This is the height of this triangle. So this base, we have the values here is 25 here and is 10 here. The space will be 25 minus 10. So you can write it as 25 minus 10, or you can put 15. So that is 25 minus 10. That is the height of the triangle from here to here is 25. From here to here is 10. So it will be 25 minus 10 and to get this distance. Use your calculator. 10 times 35 will be 350. 10 times 10 will be equal to 100. Plus half is 0.5, ne? So this is 15 times 10 and multiply by 1/2. 1/2 is 0.5. So this will give us 75. Next step, you add this. This is 175 plus 350. And the answer will be 525. This is the displacement, the total displacement between this point and that point. Last question is looking for the average velocity of the vehicle. So to calculate average velocity, we use the formula S equal to VT, or velocity equal to rate of change of displacement. This velocity is the average velocity. Now we have three things that are happening from 10 constant, then it accelerates. So we cannot take these velocities and divide by 3. We are looking for the average, but we do have the total distance or total displacement. So where there is this S, we can put 525 equal to the V average is the unknown. Then multiply, this vehicle took 45 seconds. You multiply by 45, you divide both sides by 45, and you get your answer of the average velocity as divide by 45 is 21,667, 21,667 meters per second. And that is how you solve it. This is how you solve it. Depending on the shape, your section, you always close your diagram, and the area under the graph represents displacement. And you divide it into rectangles and triangles. You add all those areas so that they can give you the total displacement. It is represented by area under the graph. So this is the graph line. This area is under the graph, is underneath the graph. Thank you.